Hey there, it's Jason from Codemanship with another video diary entry, again on the topic of inner loop agility. Before I get into the body of this video, if you're enjoying these videos or finding them useful, like and subscribe, and ring the bell for notifications for new videos. So, inner loop agility. So the question naturally comes up, what are these inner loops? What are the inner loops of software development? So I'm going to demonstrate those today with a simple example. Now you can probably guess what they are. They're the micro feedback loops of software development, like test-driven development, refactoring, and continuous integration, the things that we would be doing many times a day, basically, those feedback loops that we go round and round in. So I'm going to do some test-driven development that's going to demonstrate all of these loops, including continuous integration. And I'm going to be doing it with a very simple example, which is totaling up the items in a shopping basket. So first of all, let's talk about TDD. If you're not familiar with TDD, test-driven development, as the name implies, just means that you are driving the design and development of your code using tests. So the feedback loop is very simple. We start by writing a failing test, and then we write the simplest code to pass that test. And then if necessary, we clean up the code, we refactor to make the next test and the test after that and the test after that easier. So we look for things that are going to make code harder to maintain, harder to change, like duplication, complexity, readability, all those kinds of things that we need to look out for. And if necessary, we refactor before we move on to the next test. So I'm going to start with the simplest example of a shopping basket I can think of. And the reason I'm doing it this way, rather than just doing a complicated example, is to keep that feedback loop tight, keep it short. So what's the simplest example of the total of a shopping basket I can think of? Well, an empty basket. So it has total of 0 when empty, or emoti. I don't know what you would get for a total of an emoti basket. Okay, so I'm just going to assert, so I'm going to use the strict equal there. So I'm working backwards from the assertion, which is a good habit to get into, because then you get the setup you need for the question you want to ask. So you're totally test-driven then. And let's go object-oriented, and let's imagine that basket is a class. Okay, and we're going to give it an empty list of items. So let's put in some delimiters just in case. And working backwards from there, let's create that class. It's guessed quite correctly. So the constructor takes a list of items, and we're going to need a total method as well. So let's just imagine that we have a total method so that the code will run. And now let's see the test fail. So this is what we call the red light, see the test fail. Okay, and that's what we're expecting to happen. We're not actually returning anything from the total method, so we're expecting it to fail for this reason. Okay, and then because we want a short feedback loop, we just do the simplest, quickest thing we can think of to get it to pass. That would do it. Okay, so make your test pass, and then we move on to the next test. But before we do that, let's demonstrate the second of the inner loops, and that's this thing called refactoring. So refactoring is essentially cleaning up the internal design of your code without changing what it does. And you do it as a sequence of things called refactoring. They're a bit like the moves of chess. They have very well-defined code mechanics. Like if we want to rename that total method, we would also need to update any references, any calls to that method, and that would be a single step, an atomic step that preserves the behavior of the code, so the code still works. So I'm going to do a single refactoring here. I don't believe that our basket class, which is source code, not test code, really belongs in this file. So I'm going to do a manual refactoring here. I'm going to move it to another file, keep it away from the test code. And in order to do that, I will have to import it. So let's imagine I have a basket file there. Oops. And I think WebStorm will invite me to create that file for me in the right place. Okay, let's add that to our Git repository. Okay, so let's paste in the basket class. And now let's export that. It would be really nice if this was an automated refactoring, JetBrains. But let's export that basket. So that's like a single move, if you like. We have to do all of those things in one go to get the code doing what it did before, to get the code working again. So let's check. No, does not like that. What did I forget to do? Where's our basket file? Ah, there's the hint. It's not modules export, it's module export. I do apologize. I've literally this morning come back to JavaScript after a few weeks. So that's why it's important to run your tests after you do each refactoring. So we've done our refactoring, our tests are green again, and that's good news. But we're obviously not finished. It's not always going to be 0. So we need to add more tests. So we're going to go around in this TDD loop again. And we'll do this on the average day many, many times. So hence we call them micro loops or micro iterations. Okay, let's write another test. I'll just put a delimiter in there just in case. How's a total of the price of a single item? So we're going to put one item in there with a quantity of 1, and we would expect our total to equal the price of that item. So again, I'm going to work backwards from the assertion. So these are very quick loops usually, and this time, let's say the price of that item is £100. We would expect our total to be equal to that price. Okay, let's declare our basket, working backwards from there. But this time it's not going to be an empty basket. We're going to put in a new item with a price of 100 and a quantity of 1. Let's create that class item. That's the price. No, I don't want price, so thank you very much. And that is the quantity. Okay, that's all we need to see the test fail. So let's run the test and see it fail. Okay, that's exactly what we expected to happen. So we're halfway through this loop again. To get this to pass, again, we want to do that as quickly as possible. So maybe if we just check to see if items, we'll need to assign that to a field first, I think. Okay, let's create that field. So length, I think, is the one to go for. So if the length's not greater than 0, in other words, if it's empty, return a total of 0. Otherwise, return a total of 100. So again, what's the quickest, simplest thing you can think of to get it to pass? Now, actually, I'm going to run both of these tests because we're changing code that affects both of these tests. There you go. Both tests are green. So we take another step forward. We've gone around the loop one more time. Again, I don't think item really belongs here. So let's do another refactoring. Let's move item into its own file. We'll put that in the root folder. Let's call it item. Okay, and we will be invited, no doubt, to create that file. Thank you very much. And module exports equals item. So we export it. So again, it's a single step that takes us back to where we were. And now let's rerun those tests. So tests are really, really handy here. Okay, and that seems good. So we can go back to our test now. Let's move on to a slightly more complicated example. What if there are 2 items? Has sum of prices of 2 single items. Okay, so I'm hopefully choosing my test names carefully here. So if we got one that has a price of 100 and another one with a price of, say, 50, we would expect the total to be 150. So we're sort of in these little micro feedback loops, fleshing the design out one little design decision at a time usually. So taking these small baby steps. And these micro feedback loops are all really about taking these baby steps. So we can do this safely. Okay, so we need our basket. There's our basket. And this time we're going to give it 2 items. So an item with a price of 100 and a quantity of 1. And we'll do another item with a price of 50 and a quantity of 1. Okay, there we go. So there's our basket setup. And when we run this, it's just going to return a hard-coded 100. So let's run the test and see it fail. Okay, that's exactly what we were expecting to happen. So now we've got to get a little bit more sophisticated. So let's take a look at our item. We need to know the price, so let's assign that to a field. I'm just going to do it. I'm not going to go with getters. I'm just going to do it the undisciplined way. So let's have a field that will be visible called price. And in our basket, we're going to need to know the price now. So let's, okay. So we got our items. Let's reduce that. So we're going to need a function. So let's have our total and our item. And we're going to total plus item price. Seems reasonable. And we're going to need a starting value of 0. Okay, which means we probably don't need this anymore, because if there are no items, it's just going to return 0, hopefully. Okay, so we're making it more sophisticated now, taking a bit of a step forward now. Hopefully this will work. Bingo, a bit of functional programming in JavaScript on a Sunday morning. Honestly surprised I remembered how to do that. Okay, so we're making it more sophisticated. And I think at this point, I'm reasonably happy with the design as it is. I think this is relatively straightforward. There's some duplication happening in our tests, but these setups are all different. And frankly, I'm not sure it'd be worth removing it, because probably I've only got one more test that I need to do. So I'm just going to move on to the next TDD micro feedback loop. So has sum of subtotals of item subtotal as total of price times quantity. So we're going to do one more example, but this time the quantity is going to be more than 1. So let's imagine the price is 100. We would therefore end up, if there's 2 of them, with a total of 200. Total, okay. And let's declare our basket. And this time we only need the one item, because this isn't about multiple items. This is about quantity. So let's give it a quantity of 2. And this will fail because it's going to return a total of 100. It's always assuming a quantity of 1. So let's run that test. See it fail. That's exactly what we expected to happen. So we're halfway through that loop again. Okay, now let's go back to our basket here. First of all, we're going to need to let's assign quantity to a field. We'll need that. I'm going to be very undisciplined and make it public like that. And let's go back to our basket now so it can see both of these. So very simply, it's just price times quantity. And that should complete the design. So let's run the test and see. Okay, 102. This is why tests are so very, very useful. Okay, a schoolboy error. Okay, so my tests are protecting me, and that's why they're so important. Protecting me from making these kinds of mistakes, and we'll talk about that in a minute. Okay, now we're back on a green light. Let's just run all the tests and make sure that they're all passing. Good. Okay, nice quick test suite. So back to our basket. There's one little flourish here, I think, and that is this thing here. So this is an example of what we call feature envy. In other words, basket knows a little bit too much about the internal features of item. And if we want to reduce the coupling between those two classes, we might want to move this bit of code to where it really wants to be, which is part of item. So let's first of all extract a method in our class there. Let's call that subtotal. Seems like a good name. Price times the quantity. And immediately after doing the automated refactoring, even though it was automated and therefore isn't supposed to break the code, I must immediately rerun my test. So when you're refactoring, you do a single refactoring, like for example, extract a method, and then rerun your test. Very important. Okay, now this method doesn't really belong here. Now we don't have move method. That would be too difficult to do in a dynamic language like JavaScript. So again, this is one I'm going to have to do manually. So what we're going to do is we're going to flip it around. So rather than saying, give me the subtotal of this item, we're going to tell the item to give us the subtotal. So let's cut that. Okay. And let's say, no, this is actually the item subtotal. And we don't wish, well, we can go with that for now. Let's create that method, subtotal on item. Oh, actually, we don't need to do that. We can just paste. Okay. So it's going to return. And again, we need to retarget it. So let's make it point at itself. It would still work if we didn't, but let's do the complete refactoring. And there you can see it's grayed out item. So item has become redundant as a parameter. And immediately we rerun our tests. That's what they're there for. Do a single refactoring, extract a method, move a method, and then rerun your tests. And we no longer need this. So let's just get rid of that. We can do that very easily here. And rerun your tests. So we changed the signature of that method. We deleted a parameter. And these are now redundant, these parentheses here. We don't need those, so let's make it a bit more readable. Okay, so we've done another refactoring. Basket is looking pretty simple. Item, now here's the thing. We can hide these in other languages like Java, for example. We can't really hide them in JavaScript, but we can at least document the fact that they are supposed to be private. They're supposed to be hidden. So let's rename price. Let's put a little underscore under there. So we're sort of saying, don't access this directly, please. Okay, do your refactor there. And immediately, even though I've done one little thing there, immediately rerun my tests. Now, we can do the same thing here. So although we can't make it private, we can document the fact that it is supposed to be hidden. We're not supposed to be accessing it directly. Okay, and let's rerun our tests. Okay, so I'm a little happy with item now. I'm not breaking the rules of object orientation. I am encapsulating price and quantity. I'm hiding the data. So I'm happy with basket. I'm happy with item. I'm reasonably happy with the tests. And that might be a good point. Now that I've got my basket working, I might want to think about having done, 15, 20 minutes work. Maybe it's time to share these changes with the rest of the team. And also it'd be quite nice to have a backup. So what I'm going to do is I'm going to commit this, and then I'm going to push it to my GitHub repository, to the main branch. So let's just make sure everything's in there. Okay. So we added a basket and total. So we got that working. Okay, now, before I push this, so there's a very important point here. Number one, the only reason I'm committing at all is because all of my tests are passing. So that's always the step you would take before you even think about committing. Don't commit stuff that doesn't work. Because your commit, you really want that to be a history of versions of the code that were working. So you can get back to working code very easily and safely if anything goes wrong. But also, because I am actually thinking about pushing this to the main branch, definitely don't do that unless all your tests are passing. So all my tests are passing, I'm committed. I'm going to push this to the main branch, but that's not where it ends. As you'll see, there's another step that happens after this. There's the third of these inner feedback loops that we're going to take a look at in a minute. So let me just push this first of all, and then we can go take a look on GitHub and see what happens when I push my changes. So off it goes. Lots of good stuff to share with the team. Okay, so I've pushed that to the main branch, but just because it's working on my computer doesn't mean it works on everyone's computer. And as you will see, I've set up an automated build, which is just queued up. So hopefully it will start soon. I might have to give them some. Oh yeah, so it's the build has started. So it's going to go through a bunch of steps here. It should be relatively quick. It's done all of its jobs. Yeah, lovely. So you'll see it spins up an environment. It runs a bunch of stuff. So sets up the job, spins up a node environment, does npm CI and all that kind of stuff. And then very importantly, as you'll see here, it then runs the test. And the reason we want to see this build happen is because we want to make sure that our software passes all of its tests on other machines, that it's not just a quirk of the configuration of our local machine, that those tests just happen to be passing. So we get what's called a corroborated build, usually on some kind of build server or build machine, in this case on the cloud, hosted by GitHub very kindly. So every time I check in my changes, every time I push my changes to the main branch, we wait for that corroborated build. And that means we can be sure that what we've got on that main branch is working and that we could release it if we want to, but also that other members of the team can pull my changes and merge them safely with their code because they're confident that what we've got sitting on GitHub is actually working. And we call this continuous integration. So this is the third of those inner feedback loops, those micro feedback loops. And this is, again, is something that you would probably do many times a day. So there's 3 inner feedback loops: test-driven development, write a failing test, write the simplest code to pass the test, and then very importantly, refactor to make the next test and the test after that easier. So that's one micro feedback loop, and you'd be doing that, every few minutes. And then there's the refactoring feedback loop itself. You do an individual refactoring, like move a class or rename a method or whatever, and then immediately run your tests. And those micro feedback loops should be in the order of seconds, really, ideally. Round and round we go. And then finally, continuous integration. That's when we're continuously merging our changes with everyone else's changes and seeing that they do indeed work, ideally on a separate machine, for example, on a build server, so that we can be confident that what's sitting on our main branch actually works and could be released if necessary, but also so that the team can regularly update their code with changes that other people are pushing to the main branch. So we're all keeping in step and avoiding that merge hell that happens when we all do it at the end of the week, for example. So 3 inner feedback loops, but there's a 4th one, which I demonstrated you may have counted many, many times more than the others. And that's this one. Let's do it from the command line. That feedback loop. Building and testing the code. Depending on what environment you're in, it might mean compiling the code, it might mean interpreting the code or whatever, but building and testing the code to make sure that it stays working. Now, you would have seen in the last 20 minutes or so me do that many, many times, dozens of times, in the course of 20 minutes. Now, that's why the innermost feedback loop, when I talk about inner loop agility, what I'm usually really talking about is that build and test cycle. How long does that take? Because it's the loop within those inner feedback loops. It's the innermost feedback loop of them all. And if it takes a long time to build and test your software, as you've seen in previous videos, and if you didn't watch those videos, really go back and take a look. As I've kind of demonstrated, if that innermost feedback loop is too slow, then that slows the whole system down. That slows cycle times down, creates long queues in your backlog, in fact, the existence of a backlog at all is kind of an indication that maybe there's a problem. But it creates huge delays. It introduces lots of latency into your software development system, and can have quite a profound effect. So that's the one that I always encourage teams to target, to focus on the most. How long does it take to build and test the code? Now, in our case, it doesn't take long at all, 18 milliseconds. That's no problem at all. As this code grows, if we're working on a real production system, that time will start to build up. And you've really got to keep an eye on that. You really do have to keep an eye on that and work fairly continuously to keep those build and test times as low as you can. It also requires you to approach the design of your software in a certain way. These tests are tests for something that is, in terms of design, very simple, and in particular doesn't have any external dependencies. It's not talking to web services or databases or message queues or anything like that. So they run really fast. Real production software usually is a lot messier than that, has lots of external dependencies and all kinds of things that could potentially make our tests run really slow. So you need to architect your code. You need to be very fastidious about architecting your code in a way that supports unit testing, that supports fast running tests. In particular, using dependency injection where there are dependencies to make it so that you don't have, let's say, for example, we had a database behind this and we were reading items from a database and then calculating the total. Now, if I'm unit testing that calculation, I don't really want to connect to a database. So we need to be able to fake the database, for example, to create a stub object that pretends to fetch the data from the database, but pretends to fetch that list of items so that we can easily and quickly unit test this. So there is a lot of effort, a lot of skill, and a lot of investment that goes into keeping those build and test times as low as possible. It really is worth it. A lot of teams underinvest. Too many teams underinvest in that. And their test suites start to grow and become bloated, and the code gets messy and horrible, and dependency problems and performance problems. And before you know it, you've got a build and test cycle that takes 10 minutes or 20 minutes or half an hour or a day. And then because that innermost feedback loop is too slow, that slows everything down. Now, there's a couple of things I just want to finish talking about in this slightly longer than usual video diary. So a lot of teams try to find ways around this. So rather than investing in and working on making those build and test cycles as fast as possible, they try to kind of sidestep it. One of the ways in which they sidestep it is to not run the tests or not run them very often. They think, well, we'll save a lot of time if we don't. Let's say we run the tests every hour, or we run the tests overnight, or whatever they do. And this might seem logical, but you then hit another principle of software development. And I've got a little slide prepared just to get us onto that subject. And this is all about the relative cost of fixing bugs. Basically, the longer we go before we realize that we've broken the code, exponentially, the more it's going to cost us to fix it. And teams that run their tests less often, teams that test less often, tend to produce software that is much buggier and end up spending a lot more time bug fixing than the time they saved not running the tests or not optimizing the tests. So this really doesn't work. It really doesn't work at all. I can promise you that. There's no way around it. You want tests that you can run frequently. And the less often you can run those tests because they take too long, the more time you're going to spend fixing bugs. So much so that you're going to end up wasting a lot of time. It's going to make you go much, much slower. So that's not really an option. It's unfortunately not an option, but a lot of teams still try to take that option, but it doesn't work. And I've seen over the last 30 years of my career so many examples, including examples that I worked on when I was less smart and less experienced, where we took the shortcuts and realized they're not shortcuts at all. That's actually the long way, because it's quicksand. It really is. So don't do that. That's option number one. Option number two is usually one that the managers try to take. I don't know why I ended that presentation, because it's the second slide, which they say, well, look, if development is slowing down, obviously what we need to do to increase the throughput of features is to hire more developers, more worker threads on the team. This also is quicksand. It does not work. Larger teams tend to end up going slow, and the reason is well understood from Fred L. Brooks' book, The Mythical Man Month, which will probably be updated to the Mythical Person Month these days. He talks about what happens when you add more and more people to the team, because we're not working on our own things. We're not working in isolation. We're working on things that are connected to things that other people are working on. And that means we have to communicate. We have to communicate quite a lot. And the more people you add to the team, the more lines of communication you add to that situation until the team becomes saturated. Essentially, they're spending all their time in meetings and nobody's getting any work done. So that is also quicksand. That does not work. So skipping testing or testing less often, quicksand. It doesn't work. It makes you go slower. Adding more developers to the team, quicksand. Doesn't work. It makes you go slower. There really is no way around this. Of course, there are things you can do. If your tests are running slow, you could throw hardware at it. You can parallelize tests, all kind of low-hanging fruit. But ultimately, you do have to invest, however you do it, in making sure that those build and test cycles are fast, because that's the innermost feedback loop. And that determines the overall cycle time of software development, whether you like it or not. So there you go. Those are the inner loops, and they all point to the innermost loop, which is build and test, build and test, build. You saw how many times I did that. Now imagine those tests took 10 minutes to run. How long would this video be? Anyway, that's another video diary entry for a rainy, sunny morning. I hope you're safe, and I'll see you soon.